Okay, so again, we're gonna build off an example to get to this end product of this kind of terraced amphitheater that blends back into the landscape. So you'll see that there's this part where we have, it's a little bit easier to see at this angle, these kind of terraces, but then it kind of nicely blends back into the existing topography because when you do terraces, most likely you are going to have a huge impact on the edges. You can see here too um, what the existing topography is versus what our terrace looks like when I get to this profile. So you can kind of see how some extrude out of the topography, some cut into the landscape. So there is somewhat of a balance of cut and fill. You can kind of see areas where the existing topography is versus the new topography is going to be. And in this process, it's going to require some effort of kind of going back and forth between Rhino and Grasshopper. It's more than what I usually do, but it's really important that you do so in this way. So again, you have a little bit more freedom over the design as well. So again, I always kind of like to start showing some of those examples or inspirations. So here's where this idea came from. So this came out of Sasaki's office, where again they take this idea of kind of terracing part of the landscape for this amphitheater kind of area, but then you can see how the topography in this case blends back up, going up. Ours is a little bit different of that blending, but regardless, you can do it in both ways. So um, there's again a lot of different iterations to get to that end product. So let's go ahead and minimize that. So again, this is where we're gonna kind of get to as our final product, and we're also going to build off of this a little bit. You can see in that example, there's a little bit more to it, right? Like you can't just have the earth shape like that. So you want to add some retaining walls as well as some accessibility. The accessibility will probably have a lot more variation. That existing example showed how a stairway kind of went through the center. You can do it that way. You could have something more of a kind of meandering slope as well. So that will require some effort, but we can show that in future videos as well. And like I said, that example, it almost took the existing topography and draped down. This one, it's kind of going up. Like I said, either can be interchangeable pretty easy with the script. Um, but yeah, so let's go ahead and jump in. It's a little, again, a little more comprehensive than other scripts, but it'll still turn out well. So again, we're starting with an existing topography. And then the next thing you want to do is actually draw out the footprint of your boundary. So I've got them all as four separate curves. So there's the top, the bottom, and then there's these side profiles of our footprint as well. And again, you can kind of customize those however you want. But you want to keep those as four separate curves. So I'm not going to draw those out. They are perfectly on the plane as well. So it's not that difficult. Again, if I wanted to, I can just show you real quick where it's just, here's one, here's the other, and then for even the other ones, it's a completely different type of curve. But again, it's just doing something like that. So this is just much more exaggerated in size, but there it is. The key is that you do make sure that it's actually within that footprint. So this one's a little bit too big, so I would just make sure to scale it a little bit. So I can do it uh, like that. And so there you go. So it's really simple. So once you do that, we can start to build this script. So first thing I'm going to do is, again, reference my surface here. I'm going to, again, divide it into a grid of points, and I want there to be a specific spacing for that. So I'm going to go to Surface, get the dimensions of my surface. So how long and how wide it is. And I'm going to divide that value by a specific uh, interval or spacing of these points. I usually like to work with one uh, feed so it's nice and dense. And then from there, I can now go to my surface and divide it by number of points in either direction. Oops. Let's make sure we plug in the right ones first. So there you go. So now I got equal spacing of 1 foot between each grid point. So the next thing we want to do is make sure that we're only affecting the grid's points within our actual boundary, so, or our footprint. So I'm going to go ahead and select all 4 curves. Again, I want to keep them separate in this case. It's not key, but it does help for other things. So next thing I'm going to do is reference those curves. So set multiple curves, and then I'm just going to go ahead and join them here. I actually want to keep them separate for a step coming up not much longer from here. So from here, now I've got a nice closed curve, so it's important that it says closed planar curve. And now I can make sure to project that onto my surface. So I've got my surface, got my curve, can turn off my points now, and now you can see it's nice and projected onto that. So I'll go ahead and turn that off. And so now I will do the analysis and do pointing curve or pointing curves. It really doesn't matter in this case, but I'm going to go ahead and flatten these points now. This is the curve I'm looking at, and again, it's going to give me this rule to follow if I want to look at everything that's either outside, coincident, or intersecting with the curve and inside. So basically anything greater than 0, because I don't want to look at everything outside. So I'm going to do operations larger than 0. So now I'll go ahead and plug that into there. Use my dispatch component to follow that pattern. If I want, I could also do cull the pattern, but that means I'd have to make sure that I'm looking at everything less than, or sorry, equal to 0 to cull that, but in this case, this is okay. But you'll see when I plug this in that, again, I'm only concerned with these points. So here's where we start to do a little bit of math and have to go back to our Rhino file. But what I want to do now is look at all these points. So I'm going to actually shift this up a little. I'm going to go to vector and deconstruct these points to find their z values to figure out what the highest and lowest point is. So I'm going to go to math, minimum and maximum, or our bounds, and see that I have a low point of 6.458 and a high point of 15.799. So this is going to kind of help us figure out how many terraces I need to have. So I'm going to go ahead and deconstruct this domain and find the elevation difference. So in that case, I'm going to subtract our high point, which is this end domain, with our low point. And that gives us a total difference of 9.341 feet. And so usually for these to be a good seating wall, you want them anywhere between 14 and 18 inches for the simplicity of converting from inches to feet, I'm just going to stick with 1.5 feet, so 18 inches. So I'm going to divide my total distance by 1.5 feet. And this is telling me that I need to have 6.228 terraces, or if you round it, it's pretty much 6 terraces. So with that, I'm going to actually reference my two curves, these profile curves. Again, this is why it's important that you don't join them. I'm going to reference those two. And I'm going to divide them by this number of points. So now you can see that I'm going to have 1, 2, 3, 4, 5, 6 segments. So this is where we're going to use to make sure that we kind of keep our terraces nice and uniform in distance. That way we don't have to worry too much about changing slope. So I can go ahead now and bake these onto another layer. And so you'll see that I've already actually got this on this terracing layer, but I'm going to go ahead and bake this onto a new one called Terrace Demo to show you again that process. So I'm going to take these points, I'm going to right click and bake it onto that layer. So Terrace Demos. I'll go ahead and turn it off since I don't really need it anymore. We'll go ahead and turn off some of this stuff as well. And I don't even need to see my surface either. So from here, now I'm going to start to kind of draw my terrace shape. So I'm going to go to top view, and I'm just going to start to kind of draw something that kind of follows the original curves. You can obviously have a little more fluctuation with it, but again, this is why we are doing this in Rhino, so that we just have a little more control over the design of these. That way they don't have to be perfectly uniform. If you want it, then you could pretty much skip this step and just connect these points to create your different levels. But at least now we can have that kind of freedom of our design. And I know that these are still kind of different spacing, but the keys that are outside areas are all equal distance. These are going to be perfectly flat, so it's not that important. It's really for the side slope. So what we want to do now is actually create these as closed curves, right? So this is kind of a nice time-saving tip to do so. So if I just go ahead and select just my curves, or I guess I can do it this way. So I'm going to use the curve boolean. And what I want to do is make sure that I don't delete my input, and that I also don't combine my regions. So now I can select all my curves, hit enter, and basically just select each one of these areas. And like I said, because I don't have combined regions, it's actually gonna, I can go ahead and show you that I'll turn off this as well. So there's that one, this one, this one. So they're all their own respective closed curves and basically going to act as our terraces. So I can now go ahead and just select these 6 closed curves and reference those now. So again, this is where I'm saying there is kind of some back and forth between this, but hey, you can't get Grasshopper to do everything for you. Okay. So now I'll go back to one of these layers. I can turn that off. And now I'm going to do the same thing where I'm going to take my curves, and now I'm going to filter out these points into their respective terraced area. So I'm going to turn that off. Now again, I'm going to go to curve, analysis, point in curves. Gonna drag that into there. And the next thing I want to do is also graph these curves so they create their own branch of data. So I'm gonna go ahead and graph this. And now again, I'll do math, operations, larger than. I can just use 0 once again. So this is again gonna help me filter out this, so I can go to sets, list, dispatch. And what's good is that it's taking one pool of data and it's gonna basically follow the same idea and branch it into those 6 terraces. So now you'll see my data tree has 6 lists with the number of points in each one. So you can probably guess that the bottom one is the 460, then 420, and the top one is our 1279 terrace. But now we've got those all nice and divided. They're still on that existing slope. So the next thing we want to do is actually terrace or project these points onto their respective plane of these terraces. So now I can type project. And I want to do a couple other things first. So I also want to make sure I put these terraces in their respective location because they are drawn on the ground plane. And there's a reason I lifted that up just so that you don't fall victim if everything starts at 0 for the script, but then it'll create some issues if you actually aren't on a designated level. So this is just to kind of help make sure that that's okay. So we know that our low point of our terrace is at 6.458 feet. So I want to, again, create their own kind of respective elevation. So I'm gonna start at this value, but I wanted to, again, take that low point and project that terrace up 1.5 feet. So I'm going to do math and add our low point. So at elevation 6.45 feet in this case, plus our 6.5 feet. That will give us our starting elevation for the first terrace. And then the step size is again 1.5 feet for each terrace elevation. And then the count is however many, terraces. And again, we can use the same value there. So 6, so that's going to give me that starting elevation. And see that each one of those intervals is 1.5 feet. So now I can project, the next thing I want to do is move my curves to those respective heights. So I'm going to move them. In the Z direction. I'm going to use this, and you're going to see it's going to do something funky, and that's because I didn't graph it. I'm going to also graph this. Now you can see that they're all at their own respective 1.5 feet interval. And so now I can take my points here and project them to their respective elevations. So watch that. So now they're all kind of nicely organized. So we're definitely getting there to get our actual terraced surface, but we do want to obviously do, like I said, of kind of getting them to match up with the existing topography. If I were to just leave it like this, I'll kind of jump ahead to show you what the end product is if you don't do this next step. So I'm going to just take these points and replace the old ones. So I'm going to go to sets, list, replace items. I'm going to drag this into here. Here's my new list of points. And then I'm also going to look at their index. Oops, sorry, I actually want this original list, right? I have the index of those items, so I'll do, that's what I need next. So I'm just gonna do list to find my index items, or index of those items, and you'll see those are now. So I can go ahead and plug that into there. Oops. Oh, there's one last thing we want. We want to also do the same dispatch. And again, we'll just make sure that we flatten this. There you go. So, like I said, you'll see that, yeah, maybe it's fine on the inside, but you can see the amount of elevation change on that outside, which is definitely an issue, and it happens on either side as well. So obviously you can just put a wall there, but it's better to kind of look at how you can begin to blend those things together. So I'm just going to go ahead and move this over a little bit more because this is where we want to start to do that. So in order to figure that out, we want to kind of compare the existing points within that terrace with these new projected points to find their elevation difference and say, you know what, like as I get further away from the center, have them return to that existing elevation point. So we're going to go ahead and just go to vector and find that distance between the original points and our projected points. So the ones that are on the existing grade versus the new grade. We're also going to use a parameter of the distance from like the center of these curves. So I'm going to do area to get those center points. I'll turn this one off for now. So basically, again, the center point, oops, let's do it of the projected ones. So these ones, right? So there's the center point for those. And basically, as they, again, get further from these center points, it'll start to taper back to the existing topography. So I may use these as our center point. Compare that to our new terrace point. So I'm going to do closest point. There's that one. Here's this one. So it's going to give me my distance parameters. I'm going to go ahead and remap these values because I'm going to use the graph mapper to get a nice blending of the topography. Can start to turn some of the stuff off. So now I'll go to parameters, input, and graph mapper. So again, what I want this to do is these all have all been kind of projected up. I'm going to use the Bezier one. So again, if they're really close, I don't want them to move. If they get further away, I want them to move back to that respective distance. So what I can do is kind of, again, think of this as my profile. It's a little bit kind of inverted. Like basically it's going to move in the downward direction. But this is kind of what we want, that kind of blending. So think of this as the top of the terrace, the bottom of the terrace. Kind of, again, it's a little kind of weird to show that way, but that's just requires minimum change for it. And now I'm going to go ahead and use the multiplication. Base off those distances. And now again, I can move my projected points in the Z direction, and I do want these to go in the negative Z direction, so I'm also going to make sure. So if you want them to actually, uh, still not quite correct that way, but um, yeah, never mind. I'm just going to do negative X. And now you can see that they do start to kind of taper off that way. So again, if you want, you can kind of keep that terrace for a little bit longer, and then it kind of makes a little bit more of an abrupt change, and then you always kind of smooth this out a little bit, but you can kind of start to see as they get to that end point that they begin to return to grade, right? If I were to do it like this, then that's pretty much what they looked like before, but now I can start to affect how they begin to, again, blend back with our topography, right? They kind of look like they just split and go up. So now I've got my new points. Let's kind of make this a little bit smoother. So you might want to even kind of exaggerate your footprint, knowing that you're going to need this space to regrade back to the existing topography. But once you do that, you can go ahead and plug this back into here, turn this on, turn this off, and now you can see that we've got them all grouped together. And now the last thing, because again, we don't want to just work with grid of points, we want it to actually be a surface. So I'm going to go to surface, surface from points. So here's all my points. I want to make sure I use the same U count plus 1, because again, 1 gives me spans, 1 needs number. So this is what's going into the U. So I'm going to drag that over to there, give it that expression of x plus 1. This is just kind of a given. And now we can see that we have our nice terrace topography. Let's go ahead and bake that onto a new layer so we can see it a little bit better in Rhino. Turn that off. So now you can kind of see how that works. Let's see what it looks like in rendered view. Pretty nice. Obviously, once you add the retaining walls, it'll kind of smooth up this kind of pixelated edge, which is fine. But yeah, what's great is that, again, you kind of see how that terrace blends back into the topography. It's obviously not that difficult if you want them to um, project down into the other direction, right? So we would, instead of them going up 1.5 feet, they'd go down 1.5 feet, but start at 0. So you can kind of do it that way. So that's another option too if you wanted to do more of a cut than a fill. I can show that in another iteration, but that's how we get to this final product. Like I said too, this is probably enough to just get that part figured out, but then we can look at other scripts to add those retaining walls, look at couple different options, look at also different options for stairways or access, whether it's stairs or ramps or other kind of elements. So yeah, this is how you begin to blend any type of major landform change back into an existing topography as well.